One of the most popular weighing indicators in the Iranian market is the SI580E weight indicator. This indicator measures 96 mm by 48 mm. Its input power is 24 volts DC. It has 4 adjustable relays, and 485 rupees network with Modbus RTU protocol, and 232 rupees serial port, and analog outputs of 0 to 10 volts and 4 to 20 milliamps, which you can use to send commands to PLCs or other devices. Additionally, this weight indicator supports both pour, con and batching modes, which we have already covered in previous tutorials. Now, let's calibrate this indicator together and show you how to connect it to a PLC. We have connected the load cell to the SI580E indicator. To start the calibration, press and hold the F button for a few seconds. At this point, it asks for a password. Press the TER button 4 times, then press the F button. Now, press the TER button once to enter calibration mode. Pressing TER again takes you into the calibration process. The first step is to enter the load cell's capacity. Our load cell is 30 kilograms, so we enter the number 30. Pressing F acts like an enter for us. The next part is the division, which we have explained in detail in previous calibration tutorials, so you can refer to those if needed. We set this to 1/10. Here, 10 feet means the empty weight or dead weight. I press F here, and we need to wait a few seconds. It will start counting. So here we have to choose 10% of the maximum capacity of the Lutzel here. For example, our Lutzel, which is now 30 kilograms, 10% of it becomes 3 kilograms. So I have to enter 3 kilograms here now. So here, using these directional generalities, I'll zero it first. And through this generality, I set it to the number 3, press the F button, and now the water comes in. When the water comes in, we have to place the 3 kilograms weight on the load cell. Let me say again, this 3 kilograms is 10% of the load cell's capacity. So, we press the F button, it starts counting, and after a few moments, a number appears here, which we don't need to worry about. It says, calibration end, which means it's finished, and we press the F button. We can see that it's showing us the weight. Now, if I put a 1 kilogram weight here, you can see that it's showing us 1 kilogram. So, our display is now calibrated. Now, we've connected the SI582E display to the 485 serial port of the CLS PLC via the 485 rupees network. Now, what we want to do is, we've written a very simple program in the XG5000 software, and we want to have the weight value that's being shown on the display available in the PLC. First, on the SI580E display, there are some network-related settings that, as you can see, we need to configure according to the table. After configuring the display settings, we enter the XG5000 software. In the XG5000 software, we've used a move instruction. For its input part, I've set MWORD 100, and for its output part, I've set it to out, and I selected the data type as integer, and as we've explained in detail in previous tutorials, we need a table that we have to fill out for the network. I set this to read, because here we want to read the weight. The important point is that in this section, as we mentioned, there is a read area and a save area. Here, we need to enter the Modbus address of the weight display, specifically for the current weight section, that is, the weight it's showing us. Through this section, we can enter the address. As you can see in the table, the address for current weight is 11. Since we need to enter its hex value here, which is B in hex, we enter 3000B. And the MWORD that is supposed to save this for us, we set it here. It's a decimal place that we've meticulously set for the display. Less than break time equals 0. 5s greater than now. If I carefully add a 3 kg weight to this particular setup, you can clearly see that it's now showing precisely 4 kilograms. So, that's precisely how this system fundamentally works, and it actually includes a decimal place as well, which is quite important. Less than break time equals 0. 5s greater than if we specifically want the PLC to show just 4 here, without the decimal point, then when we are calibrating and entering the division factor, we absolutely should not account for the decimal point at all.